Picture this for a moment. You arrive at the gym having eaten nothing at all. No breakfast, no energy drink, no protein bar grabbed out of habit, just your body moving into training without fresh calories coming in. For many people, that idea immediately feels uncomfortable, even unsafe, because for years we have been taught that eating before exercise is mandatory, that food is the direct source of strength, and that training without it will automatically leave you weak and depleted. That belief is deeply embedded, repeated so often that most people never pause to question whether it is actually true. Feeling energized versus being fueled. What often goes unexamined is a simple but important reality. The meal you eat shortly before your workout is not the fuel powering that workout in real time, at least not in the way most people imagine. Understanding this distinction changes how fasted exercise should be viewed entirely, because feeling energized and being fueled are not the same thing. When you eat before training, your body releases hormones in anticipation of incoming calories, and those hormonal shifts can make you feel alert, motivated, and ready to move, even though the food itself has not yet been converted into usable energy. Where workout energy really comes from. The energy your muscles rely on during that session was stored well before you stepped into the gym, often hours or even days earlier. That leads to a more interesting and far more practical question. If the fuel is already inside your body, what actually happens when you train without eating? And why do some people report feeling more focused, lighter, and more in control when they do? To answer that, you have to understand how the body truly produces energy and how it chooses which fuel to use. The two energy systems that power your body. Your body stores energy primarily in two forms, and they function very differently. The first is glycogen, which is glucose stored in your liver and muscles and serves as the most convenient and quickly accessible energy source. In a typical adult, glycogen stores amount to roughly 400 to 500 grams, which translates to about 1,600 to 2,000 calories of readily available energy. Depending on how active you are, those reserves can last anywhere from half a day to a full day or more. The second form of stored energy is body fat, and this is where perspective becomes critical. Even someone who appears lean carries tens of thousands of calories stored as fat tissue. This is not emergency fuel or last resort energy. It is a vast reserve specifically designed to support movement and survival when food is not immediately available. Why the body avoids fat when food is constant. The key detail most people overlook is that the body will always prefer the easiest fuel first. As long as glycogen is readily available, your metabolism will continue to rely on it, not because fat is undesirable, but because glycogen is faster and simpler to use. When food is constantly coming in, especially throughout the day, the body rarely needs to practice burning fat efficiently. Over time, this flexibility weakens, and that is when people begin to feel dependent on eating before every workout, even though the energy they need is already stored. The myth of pre-workout fuel. This is where the common narrative around pre-workout nutrition quietly breaks down. Food consumed shortly before training does not move directly into your muscles and suddenly become fuel. Human digestion simply does not work that way. After a meal, food can remain in the stomach for several hours before it is broken down enough to enter the small intestine, where nutrients are absorbed gradually over many more hours. This means the calories from a pre-workout meal are not immediately available during the session itself. They are being prepared for later use. Why eating still feels energizing. So why does eating feel energizing? Because your brain anticipates fuel. Hormones such as insulin and dopamine shift in response to the expectation of calories, creating a sense of readiness that feels like energy, even though it is not the same as actual fuel availability. Once this difference is clear, another question naturally follows. If fresh food is not required to power movement in that moment, what changes when glycogen levels begin to decline? What happens when glycogen runs low? After roughly 12 to 16 hours without eating, glycogen stores are reduced, though not completely depleted. When this happens, the body does not panic. It adapts. It begins to rely more heavily on fat as a fuel source. Fat cells release fatty acids into the bloodstream, and the liver converts a portion of that fat into ketones, which can be used efficiently by both muscles and the brain. Metabolic flexibility. A forgotten survival skill. This shift is not extreme or unnatural. It is a normal biological response that humans relied on for most of their history. The ability to move smoothly between burning glucose and burning fat is known as metabolic flexibility, and a healthy metabolism is one that can adjust based on availability rather than being locked into a single fuel source. Frequent eating, particularly of refined carbohydrates, reduces the need for this flexibility, not because something is broken, but because the demand is removed. Why fasted exercise unlocks fat burning. Fasted exercise reintroduces that demand in a controlled way, encouraging the body to access stored energy calmly rather than under stress. As this process begins, the internal environment changes in meaningful ways. Insulin levels drop, which is significant because insulin's primary role is storage, not fat burning. When insulin remains elevated, fat is effectively locked inside fat cells. When insulin is low, that lock is released, allowing fat to be mobilized and used for energy. The hormonal advantage of training fasted. Research has consistently shown that aerobic exercise performed in a fasted state can increase fat oxidation by roughly 20 to 30% compared to the same activity performed after eating. This is not about willpower or mindset. It is basic physiology. At the same time, growth hormone levels rise. Growth hormone signals fat cells to release energy while also helping protect muscle tissue from breakdown. Fasting increases growth hormone, exercise increases growth hormone, and combining the two amplifies the effect. Why muscle is preserved during fasted training. This hormonal environment explains why many people are surprised to find they maintain muscle while leaning out when training fasted. Muscle tissue is valuable to survival, and when energy is limited, the body prioritizes preserving it while drawing fuel from fat. This is not a trick or a loophole. It is a built-in system designed to keep you functional when resources are scarce. Insulin sensitivity and long-term metabolic health. Another important shift occurs alongside these changes. Insulin sensitivity improves. This refers to how efficiently cells respond to insulin's signal to absorb glucose. Higher sensitivity means the body needs less insulin to manage blood sugar effectively. Fasted exercise encourages this efficiency by forcing muscles to draw energy with minimal insulin involvement, and the benefits extend beyond the workout itself, often lasting for hours afterward. Mental clarity and brain performance. Mental clarity often improves as well, and this is not imagination. Ketones produced during fasting provide a steady fuel source for the brain, while exercise and fasting together increase factors that support focus, learning, and resilience. Neurotransmitters linked to alertness rise, creating a calm but attentive mental state that many people recognize once they experience it consistently. Why the human body is built for fasted movement. From an evolutionary perspective, none of this is surprising. For most of human history, food was not guaranteed. Movement often came before eating, not after it. Those who became more alert and capable in the absence of food were more likely to survive. and your body still carries that programming. Short-term fasting is not interpreted as danger, but as a signal to mobilize resources and sharpen function, choosing the right type of fasted exercise. That said, applying fasted exercise intelligently is what makes it sustainable. Low to moderate intensity activities such as walking, easy cycling, light jogging, or steady swimming tend to work best in a fasted state because they rely heavily on fat for fuel and can be maintained comfortably. High-intensity efforts place greater demand on glycogen and may feel challenging at first without adaptation, which is why patience matters. Strength training while fasted. Resistance training can also be performed fasted, but post-workout nutrition becomes important to provide the materials needed for muscle repair. While fasted exercise offers benefits, it is not appropriate for everyone. Pregnancy, certain medical conditions, medication requirements, or a history of disordered eating are all situations where caution or professional guidance is essential. Safety signals you should never ignore. Fasted training should feel controlled, not punishing. Persistent dizziness, confusion, or weakness are signals to stop and reassess, not signs of discipline. When done correctly, fasted exercise is not extreme or reckless. It is simply a tool that works when used with understanding and restraint. The real goal: control, not suffering. Your body was designed to adapt, to switch fuel sources, and to protect vital tissue when food is not immediately available. Fasted exercise reminds your metabolism how to do what it already knows. The goal is not suffering. The goal is control over your energy, your metabolism, and the signals that guide how your body responds every day. So, now that you understand the full picture, where do you stand? Is fasted exercise overrated, underrated, or simply misunderstood? Share your thoughts, and if this helped you see your body differently, subscribe for more science-based explanations of how it truly works.